All right, let's get started. Poking bots for fun and profit in the age of asynchronous stuff. It's quite a long name, but yeah, my kid said this is a very long um, title. That and I kind of agree. Let's see. All right, let's just a little bit about myself. I'm working as security and financial industry for like over 10 years. Really, that are some experience there. But as a friend of mine told me a few months ago, I'm really a nobody, just trying to get a research done. And working the industry for a couple of years, you know, fascinated, like wife, kids, and authentication systems in this order. Otherwise, she's gonna kill me. I'm really interested in machine learning, behavior analysis. I'm a strong believer about the programmers and research will rule the world. So I'm a true believer that programming skill is a very foundational skill across all technology areas, and that's it. I think this is very important. Just as a last independent research work, I had this CVE from Dell ThinkOS Systems published, and this is just part of the things that I try to do on side and in parallel to everything else. Well, that's pretty much me. Um, the goal of this presentation, I just to give this an introduction why I got here, and this in particular this research a few years ago was working a machine learning module in order to fine tuning some false positive that I was getting from a supervised model. So was building a system that would combine supervised and unsupervised module, and it would send me a message over Telegram to tell me what do you want to do with this alert. Is this something? Is it? Do you want to mark it as an unsupervised, or how do you want to handle this situation? I want a very quick feedback, and I would like to interact with it anytime, anywhere, without the need to get into a system and do anything. So in that I developed this bot, and then I realized that okay, there is an input there. It's a menu on the Telegram that you just click and say 1 or 2 or 3 or doesn't matter. But the point is there was some input there, and when I was looking at the source code, I said, well, if Telegrams allow me to send some SQL injection screen, it could potentially be exploited. So that's what they start. And after a few months, I start seeing a lot of especially like small business trying to build their business model on the top of those cross platforms, things like Telegram and the others, because seeing this as a cheap way of deploy frameworks and front ends in platforms that they wouldn't reach if they were going to deliver, like to develop application by themselves, like to Android or to iOS, so to Apple Store, things like that. So I found it interesting and start research on Telegram bots, and extended a little bit to other bots as well. So the idea really is to raise the awareness regarding the secure tests on those bots and apps. So some some platforms call it bots, other apps, but essentially all applications and integration applications that can, tap into internal systems and bring things to the surface of those communication platforms. And I really want to share the challenge of testing this kind of application and try to set some direction for whoever is going to try it or is trying it currently. And of course, shed some light on the strategy on this, and hopefully motivate companies to include those kind of apps and their by bounding programs. So I haven't seen those explicitly on the policy, so perhaps we can change that. And of course, no, this is not about vacuum cleaners, right? They're vulnerable, but I guess nobody cares. And well, what does those bots and apps are used? Of course, where you can spot one, if we could start from there. So Discord, Slack, Telegram, Hangout, all those guys support bots today, right? Facebook, all principal communication apps are supporting those kind of things, and then they came up with this concept of other people's program, or building applications on OPP, which is other people's program, on other platforms that allows you to build your own software or program there, and then make it available in things like marketplace and on other things. So that's you can spot everywhere. Bots are everywhere to all kind of integration. You can call it bot or not. Integration apps are pretty much something that you can call it. What they do is they do process data and conversation and chats and file, right? That's all those things that they eat. I used to say they eat all those things, and what they do with those things, well, they can do a lot of things. If you add a bot to your conversation in a group, you just be aware that this bot will probably have rights to read all the messages and store it internally. So from privacy perspective, better be careful when you deal with a bot in your chat. So yeah, they do a lot of things, right? Chat group, they provide quick response. They tap into internal systems that give you quick answers. I like say if you're in a conversation in a group chat and say, hey, I would like to know the budget from 5 years ago. You just go budget year 2018, and it will just bring it back to you without the need to open a system, do something. The information that is something that you need at the time, and it's much faster. You can do a lot of quick wins right there. So, and you have a lot of examples out there. You see antivirus working in a group chat to take care of files that are uploaded there, URLs, to avoid phishing and things like that. And some businesses are building like entire front ends to offer clients and other third parties integration with their products. So it's really growing practice in the industry. And I think one important message to deliver is that the bot's not just a script. Yeah, it could be if you're just sending a message from, a server, you are just sending a message and not taking anything back or not listening to what's going on, maybe. But most of the time, it is an actual application, and it is connected to like multiple systems, interact with users and systems and everything. So it's an actual application, and it needs to be secure tested. Let me touch base on some common architectures, because I think this is helpful for us to understand. So there are different ways you can implement those bots, but the way you really see this is like using WebSockets and webhooks. You also see like regular web-based, but it's very rare right now because it's so unresponsive and not very fast. And like regular web-based is like you pretty much are searching, you are looking at the page gets fresh at like every second, 2 seconds, 3 seconds, and then you have the bots answer there, which is not really what we see today in terms of technology. So WebSockets is pretty much ruling those things, and webhooks. So, and you have a mix between mixed HTTP. Sometimes you send the request over HTTP, and you receive the response through a webhook or a WebSocket, right? So you have two ways WebSocket. You post message to a webhook endpoint, and then you receive to a webhook endpoint. So we'll go a little bit into this in the next slide. So pretty much there is a different way of doing this. You can use like pooling, which you're constantly asking for updates, right? You are constantly asking for updates. Like, is there an update? Yeah, is there an update? And they say no all day long if there isn't. But at some point, if you have an event that you are interested, it will say yes, there is. Here it is, the update. But this is a very expensive mechanism from that perspective, and it is pretty hard to scale if you're implementing a corporate enterprise environment. The webhook, though, your bot is only receive the message when there is an event that it's interested on. So let's say your bot subscribed on any message. So when you have an on message event on the platform, you will receive a post request on a webhook. What is a webhook? And a webhook is just an endpoint that your bot has access to, and it receives data through it, right? So it's pretty much a web service endpoint that the platform is configured to call whenever there is a message that is interesting for you. That's pretty much a webhook technology. And then you also have WebSockets. WebSockets is pretty neat as well. You see the implementation using either WebSockets for everything, message control, and also send and receive the message. Message control is like, when somebody's typing on another end, or there are some signals that they send between two conversations in the chat that is there. And also like the sequence number IDs to know which message comes first and organize those things. And then the front end glue together all those things and organize how it's going to show. And you have a mix of WebSockets and HTTP posts, as I said before. You send a message over a HTTP post, right, to the channel using an API, and then you pretty much receive message control and the actual message that are in the chat. You also you receive it through the WebSocket. So this is another model. So just to fly through some weaknesses of the webhook and callback implementations. So a webhook is supposed to be a kind of an obscure URL that you configure on the messaging platform, so that this messaging platform will call your bot, your web server, your endpoint over the internet in order to deliver a message or whenever there is an event, right? Most of the time this is like a hidden URL. Nobody's really should know about those things, and therefore nobody reach out to it because they don't know. So there is an obscurity there that you expect that, okay, nobody knows this URL, nobody's going to hit it, but that's probably not the case most of the time. So you do configure this URL with whatever it requires, and then it sends the post data to your webhook every time there is a message that your bot is subscribed to. Then from a weakness perspective, we see things like no authentication and internet accessible, debug enabled, and other things like no outbound restrictions and cache. All those things contribute to expose this webhook, right? Because it's an endpoint. Some platforms do not require authentication. They just suggest you to protect it via IP address and say put a firewall and don't accept any connection to this URL if you're not coming through from our IP address. May work, but there is some, it's a suggestion. There is no enforcement from the messaging platform for you to do it. You do if you want to, right? Internet accessible is like if you have this open it up to the internet, you can be reached by anyone, and if you don't have authentication, it's open to the internet. Well, you can be your bot can be attacked, right? Essentially, the bot can receive a message from anyone on the internet, pretty much. That's it, without going through the messaging platform. If the bug is enabled, that makes the life very easy. If you get a lot of debug, when you send a post request, they will regurgitate all the fields and things that is wrong or missing. That helps a lot on attacker potential. Outbound restriction helps when you have like a SSRF, like server-side request forgery vulnerability. So that makes the life of attackers much easier as well. And of course, like things like obvious names, indexed, cached, and search engines help you to spot those things in search on Google, Bing, and things like that. Right, so all those things make your webhook more exposed and vulnerable. So when we're attacking those things and talking about from the secure testing perspective, when you're testing a regular web application, you're really dealing with a request response, sometimes WebSocket, and then it goes a little bit different there as well. But essentially, when you talk about all those bots, you have all sort of different schemas, technology, protocols, and things that happens inside that you need to be aware, even to send one request. If you want to customize one request or one message to be posted to the messaging platform, you need to deal with those things. Like I'm just mentioning a few of them, things like MT-Prot that needs to be handled on the Telegram side, which is it's not a HTTP based protocol. You need to tackle this and other stuff that happens there. Even ID serialization, each message has one ID, a different ID that you need to make sure you are in sync. Otherwise, your message is going to be ignored. So there are a lot of things. Asynchronous, of course, you send a message, there is no guarantee that it's coming back. That's one. Secondly, if the message comes back, it doesn't come back in the same response. It comes back in form of other things, like it comes through a WebSocket or things like that. So it's not the same as testing a regular application. Rating limit is like those platforms enforce a limit in the number of messages that you send, how fast you send, and all those things. And you can get your account banned if you go too fast, too soon. Another thing interesting that you need to consider is like understand the rules of engagement, because this is important when you try to automate tests. And I think it boils down to be the case here. We're talking about most of how can automate tests against those bots and penetrate tools and techniques that we use in other words here inside this one. And things like bot versus bot is something that you're not supposed to do in Telegram, right? Not supposed to do, and in Slack is fine. So these things you need to consider when target a bot. What is the situation? Which are the rules of engagement? How should I proceed? So from attacking approach perspective, you have like manual tests on message from to end, which is fine, but the focus here really is on trying to automate those things, right? Manual test is fine. You go to web chat and just start typing things, like a normal person do, and you can do this as that. But the automation is like the challenge here, and automate the text on the web front end you can do using things like Selenium or Cypress. Cypress is very powerful now to perform end-to-end tests, and you can divert this and use for security as well, which use a web front end. So all those messaging platforms, they do have web front end today. It's not really common to see one that doesn't have. Make use of the messaging platform client API. Some of those platforms provide you with a client API to empower you to create your own client. You can use this API to interact with the platform and say that you are building a security client tool, scanner, whatever, to test applications for this platform. Use a bot to test your target bot. So it's a bot talking to another bot. It's a very interesting approach as well. The idea is to automate certain task criteria and then add those two bots to the same room and let one test another one, right? That's one approach as well. Create a wrapper around the API to allow other security bots to penetrate the messaging platform and read the bot. That's very challenging. So my suggestion is you need to mock things up to make some response reliable, and needs to be customized for every single test that you're going to perform against a certain target. So you cannot just, okay, let's just wrap it and run it. It's not going to happen. There's a lot of tuning there, especially when you are trying to use some time-based payload, which might not work most of the time. So, and generate false positives. Okay, another thing to consider is like regular web security scans may not find anything up front. The same reason is A lot of, first of all, track the response based on the request is challenging. It does require fine tuning. You need to check things. I said in the slide before, you have things like the IDs and those sequence. You need to control all those variables in order to have your message accepted by the messaging platform and flows through and reach out to your bot. So be aware of those things. As I said earlier, time-based payloads may generate tons of false positives because this is an asynchronous word. And the asynchronous words, you send something, you may get something now as an answer, you may not, or you may receive in a different channel. So the outcome of the message that you send, it's not always as you expect. And if there is an answer, you don't know either. So you don't know if error occurred. You don't know if something went wrong, or if just decide to not reply to you, or if it was something that got lost in the middle. So it's hard to track the answers there. That's pretty much the asynchronous paradigm, right? The response time is not constant. I was getting ahead of myself, but that's pretty much it. Payloads may have response sometime later, right? Debug messages hardly go back to the user, and that's important because if you're testing a bot or integration application, there is like the developers, and they need to be very creative to send back an error message from database to a chat a platform in the chat room. They have to be like very creative. So it requires a lot of effort to do it. I mean, this needs to be very creative, I would say. So analyze how this is very important to analyze what the bots do. So if you have a bot as a target, you need to analyze how this bot interacts with people, bots, and other chats. Like if it mentions users when replying, or if need to be mentioned when you send some message, right? You need to understand what's the entry point. When I send a message to this chat, does this bot just pick it up and do something, or I need to engage the bot, say, hey bot, does this to me, and things like that, because that will drive your modus operandi in your attack. Does it use commands? So it's very common to see things like slash something, like in Discord, even in the old IRC, which was very common to use there. Interesting thing is, can I add my bot to the same channel, or can I add the bot to my own channel? So those things may play around my strategy to see how to best approach this target. So make sure you reach the bot with the intended payload. You send a payload, you need to make sure it's not getting butchered in the between. Sometimes it does happen. So you need to check if the platform you're testing is not restricting certain types of characters. It's tricky sometimes because you need to understand, if you're using a high-level API, for example, the API might be throwing errors without even communicate to the backend. So you need to determine if it is API or it's a backend, where the validation happens, things like that. So it's kind of tricky. I need to debug. And follow rules and protocols required by the platform. So as I said, you are playing with somebody else's rules in order to reach out to the target bot. So if you don't do this correctly, it will zap your communication to the bot and you will not reach the bot. So you need to have that in mind, that there is a middleman there taking the message and looking to what's going on. Protections may be in place, so web application file could be protecting the webhooks. That's an approach. That's an interesting approach. You can have it there. IPS maybe protect the communication from to the target bot as well, doing some sort of SSL offloading and tapping into the communication. Target bot might not interact with other bots, so this happens. Some platforms don't allow it, but when it is allowed, the developers choose to not talk to other bots in order to protect from spams and things like that. Right, from attack perspective, so let's see the exploit opportunities. Of course, once you pierce through this veil, you have all the possibilities are in the table, right? File uploading processing is very common among bot applications. So you see those things all the time, bots having these functionalities. URL parsers and SSRF attacks. Well, pretty much, if you look at the presentation, which is like make SSRF great again from the past conference, you see how many possibilities there are there to bypass URL passes. So they are all in the scope. Database interactions, try to figure out which functionaries from the bot might be interacting with database. There might have protection functions that you can automate things like brute force, you know, things like that, enumeration. And you have like reports being generated here and there, integration with APIs, things like Google Docs and other things, trying to modify documents remotely to include malicious code, things like that can be done. And eventually get some remote code execution if you're lucky, right? So many possibilities there. Now, I just want to touch base a little bit on the software development side and automation, which is kind of the point that I want to get here is like secure automation through the CI/CD pipeline. First of all, those applications should have all those, because this is not just a script. As I said, this is an actual application, and you need to test this thoroughly as you do with another web application or any other application, right? So that's if you have a SAST and SCA, all those tools, that SEC tool, and the pipeline, go for it. Those will be very helpful. Now, for DAST, if you're using like a dynamic scanner, like you know, Burp, OWASP, Up, things like that, you may need a little bit more. You may consider expose a webhook just for those tests to make sure input validation, authentication, all those things are working properly, and then you can actually test those either manually or scanning automatically. Use API or bots to test for secure checks known to be important. If there are like things like you have unit tests, integration tests, put there some customized secure tests to be performed every time again to make sure nobody put a vulnerability that like something very obvious and things like that. So consider use Cypress. I wouldn't, Selenium WebDriver is probably possible as well, but Cypress is a very modern framework to test that like use it for end-to-end tests, and which is very good too. Consider that because you can use it against the web UI and you don't need to do anything else, though you can use Cypress with the web UI directly. Respect the limit when automating, otherwise your account can be banned, blocked, things like that. Don't go too fast against those things. Keep in mind this is an external environment, like an OPV, you don't have control over it. And that's pretty much what I had for it before the demo. So let me just quickly show a first demo. This demo is pretty much, we have here two bots in the same room. One bot implements a function, which is Zeus. Zeus is a bot that implements a function, and Atom is the bot that's going to exploit this function on Zeus. So what you see here is Slack open, and now I just started Zeus application, and you can see Slack calling the webhook on Zeus, sending, pretty much posting events that happened on Slack while the bot was offline, which is pretty much those dogs that you can see there. Those dogs are pretty much been posted on the Slack webhook by Slack in our webhook and endpoints. Now, well, let's just take a look how the Zeus bot works. What Zeus does is you send a message like invoice and reference number, and then Zeus comes back saying that, oh, this is the company and this is the amount of this invoice. That's pretty much just it's just an example on how a vulnerable application would work. So in this case, I have the number of invoice that is valid and exists just to demonstrate how it works. So you have the name of the company and then you have the amount, right? So if we try to do a SQL injection, for example, right, because it's clearly something that is bringing something from potentially a database or a web API, but what happens if you try to do a simple SQL injection here? If you look at the debug processing on Zeus, you see that the query are logged there just for us to understand what's going on in the back end. And the first query, it goes okay. The second one, though, only shows 1. It doesn't show R1 equals 1. That happens because it's very common on bots to ignore space. No, it's not that it ignores. It pretty much splits. Every space is a new command, or it's a new parameter, sorry. It's a new parameter for the command. So invoices the command, 1 is the parameter, right? And R becomes another one. That's why it's ignored everything, because it takes just the first parameter. Now, what we're going to do is we will run Atom. Atom has a few payloads, SQL injection payloads, and it will try one by one to see what's going to happen. First, it sends the baseline payload, which is the one that is true, and then initiate with 6 payloads and send one by one. You can see on the Zeus screen that there are many errors in the SQL, right? MySQL is just throwing up the errors because those queries are reaching the bot, and the bot is trying to execute the query, so we are interfering in the query until the Atom as a bot send a string that actually peers through and makes sense for MySQL and make the bot print out all those companies and their invoice amounts. As you can see, it sent 1, there is no response, another, there is no response, no response, no response. But when we use it and see, only thing that we did, the difference from payload 1 and the payload 6 in this case, was that we use it instead of space, we use comments in case of on MySQL. And then it went through, and then of course we made the SQL injection happen, and the bot just printed everything that came back from the database. So that's it, a SQL injection between 2 apps on Slack, one bot attacking another bot pretty much on Slack. Now the next demo is a Telegram demo. So Telegram, let's see how it goes, but this is pretty much a registration code, and we use a CLI Telegram client to attack Telegram bot in order to enumerate the right registration code. It sends a few codes just to automate and show how the automation works, and you can see that please verify it again, invalid registration code over and over again until you get an actual code that works. And in this case, I know what to expect when it accepts, but at the same time, I know what is not acceptable, right? I know the error message, so I can automate this process and make it happen. So this pretty much, this tool will be available on GitHub by the time the presentation is up. And this is the end of the presentation. This is it. Thanks so much. Connect with us in the Discord. We'll be answering any questions. All right, thank you.